we are going to kick things off with the final event at the Plug and Play Innovation Stage. We have a pitch competition coming up brought to you by Edmonton Global and Plug and Play. We'll be hearing from 4 amazing founders and some really interesting and unique companies coming out of the woodworks. So we're super excited to be here. Thank you to Edmonton Global for helping us put this together. The winner of this pitch competition is going to receive 1 spot in our Plug and Play Alberta program, as well as an opportunity to pitch on our Global Summit stage coming up in the beginning of June. So without further ado, we're going to kick things off with our first presenter. Please welcome to the floor Jag from Golu H2.
Thank you, Nina. My name's Jag Singh. I'm the Director of Business Development for Golu H2, and we make hydrogen from ethanol, carbon negative renewable hydrogen in modular units. So we've been around for 25 years, based in Edmonton, invested in product development, and initially started with a renewable diesel, biodiesel, jet fuel that was technology is licensed to Shell, which proved to us we're leaders in catalyst development and process development, as well as processor design. So what we now are attacking is hydrogen, and what we see as the barriers for hydrogen is cost, whether it's associated with carbon footprint, on-site infrastructure costs, safety, and transport. So when you're using ethanol, you're utilizing existing infrastructure that's already here, and ethanol can be stored safely at standard temperature and pressure in regular vessels and existing infrastructure. So the technology is simplified, it's one-step process, ethanol and water through our Golu H2 reactor to generate fuel cell grade hydrogen. There's no external heat required once the process is running. This can continuously run off-grid without any external energy inputs. And we're also we're able to use renewable natural gas and methanol. So one of the main reasons we have a benefit is because ethanol is such an energy dense carrier through our system. We're able to get 5 times more or 5 times less deliveries than compressed hydrogen in the same amount of volume, and over double liquid hydrogen and almost double liquid ammonia. And ethanol is safe, stored in standard temperatures, pressure vessels, and it's a non-toxic material. So it saves on deliveries as well as infrastructure, as well as just reducing costs overall and increasing safety. So our modular unit, this is on site. It's a demonstration of our 50 kilogram a day. It's just one module as opposed to a continuous series of them for the 1250 kilogram unit, which is our standard size. And this allows us to produce 50 kilograms a day today. We're already producing it. We have local partners who are discussing offtake, and we'll be ramping up to 100 kilograms soon. So our solution is completely off-grid with just ethanol and water to generate hydrogen. That hydrogen can be used either for fuel, transport fuel, for heat, or for electricity. And they're really efficient through fuel cells, which is what makes hydrogen a great fuel. It's flexible, allowing for both EV and fuel cell refueling at one station, as well as off-grid power. This was a concept developed for a Eastern Asia partner who wanted a Golu H2 city. Basically, our unit can provide either electricity, transport fuel, or power, as long as it's distributed throughout the system, throughout the city, using just ethanol to transport. So this is our standard unit, 1,250 kilograms a day. We reduce over 10 tons of CO2 emissions, and this is carbon negative renewable hydrogen. So we have add-ons for dispensers, chargers, working with OEM partners and the leading companies in the world to get the best equipment to our customers. So we made a solution for buses as well, because this can work with existing bus infrastructure at all of the stations, just converting from diesel to ethanol. And then this is an example to show how efficient our process is compared to solar power. It takes 43 football fields of solar panels to do what we can do with our 40-foot container, and it'll take a 1.5 electrolyzer to take all that electricity from the solar farm, which we do with our ethanol tank every 5.5 days. So this is a fuel cost comparison. This was using USA numbers. So diesel's about $86,000 a year. Our unit's about $30,000, and then distributed hydrogen's $115,000. So we're probably close to 4 times less than distributed hydrogen, and then almost half of what diesel, or 1/3 of what diesel has. Same with on trucks, we're about half. The efficiencies are a little different for trucks, so it's a little bit different, but for the distributed hydrogen, still around 4 times less. We have funding partners as well.
1 minute to go.
Thank you. And we can operate or generate, we have funding partners who will fund, own, maintain the units, and then you can purchase hydrogen as a service. And this is the first time we're offering, or someone is offering carbon negative renewable hydrogen as a service. And then our funding partner also can work if the package wants to get purchased rather than the hydrogen. So we overcome all these barriers, carbon footprint, on-site infrastructure, safety, and transport with our one unit that can generate hydrogen from ethanol. So we're gaining recognition by being in places like this, which is great. And then, you'll see us around. So feel free to come and ask us if you have any questions, and please ask away.
So you mentioned offtake right now is what you're working on. What are the other large barriers that you're encountering right now to scale and grow?
Well, one of the things is nobody makes hydrogen like this. We're the first company in the world to do this. So it's a thermal catalytic reaction, and bringing that forward is always a little bit of a challenge, and then going through that process. And yeah, at the end of the day, it's a 1,250 kilograms unit, so fueling stations would be great, but they don't have that offtake at the moment. So that would really help. And the right partners, I guess.
What does the right partner look like today?
Well, someone who could take all of that. So for example, if there was a industrial plant who would need all that hydrogen, we could easily do that. Something like this where 20% is blended into the building, that's great. We could also blend our hydrogen into something like that to help to decarbonize, increase efficiencies.
You've been in business for a long time, have existing clients. Where do you say right now your key markets are for going to market? Actually,
we're getting a lot of interest from local partners as well. So Edmonton International Airport, Edmonton Transit. We're trying, the UK as a funding or refueling station network developer is also very interested. They're one of our first real projects coming forward. And then there's a potential client in the US who's an on-grid utility provider who's blending our hydrogen into the natural gas line, which we all see it here. It works perfectly fine. And that's where they would go to lower their GHG emissions and overall carbon. And yeah, we've raised about $5 million in a seed round. And we've invested over $40 million into this technology since its fruition. So, and where we're at now, we're generating hydrogen on site. We really just need offtake to be able to take our 1,250 kilograms. So we're working on that. We're also working on getting a mobile refueler to help, partners in Edmonton who are looking for small, strange quantities, so 100 kg here or wherever. We would want to be able to fill that need.
I think we're all set. Thank you so much for your time.
Thank you.
All right, thank you so much. We are going to move on to our next speaker. Please welcome Dr. David, who is the founder of Dark Matter Materials, to the floor.
Thank you. So, I'm going to talk a little bit about a new startup company. We launched Monday. So, you want to talk about the real hydrogen economy? It's really all about between the production and the end use. All that stuff in the middle, the packaging, the distribution, storage, and transfer of hydrogen is what really costs a lot of money. So, hydrogen has to be molecularly synthesized, and most of the production in the world is done by fossil fuels. Electrolysis, which is green, which is not really that green, it only represents 0.03% of the process. So what we're trying to do, the problem is that hydrogen production competes with its own energy source, which is electricity. So in the past, people have been looking at other ways of doing it. So water gasification without electricity or sunlight was considered an insolvable problem until Dark matter spun off, officially it was created in July of last year. And we have developed a new class of earth-abundant, non-toxic, non-strategic metal catalysts. These nanocatalysts can activate oxygen, carbon-hydrogen bonds by the lowest possible energy mechanisms. In other words, what we can do is we can make hydrogen from water at room temperature. All we need is a source of water, and it's water agnostic. We don't need a fuel cell we can use a fuel cell to produce electricity, but it's not required. The nanocatalyst can be produced anywhere on demand, and water becomes your energy carrier. A little video here. So we've developed a process. You can see the different processes. Over the years, people have tried to use different methods of water splitting. There was a big announcement last October. University California Santa Cruz developed a gallium aluminum catalyst producing about 14 milliliters of hydrogen per gram per minute. There's not enough gallium in the world to do the kind of things that the world needs. But our process can produce 115. So we're 14 times higher. So if that little video would work, you could see the bubbles coming off and it's splitting. Now, if you want to see a real demo, it's right over there. It's actually working. So our value proposition. For our feedstock, we just use water, any kind of water. Our emissions are none, no greenhouse gases. Our storage is minimal. We produce it, we use it, it's done. Shipping is on-site production. So you eliminate all of these infrastructure components. Our CapEx is extremely low. You can see how simple it is. The cost of producing the catalyst and storage and things like that are only 1/3 of any of the other production systems. So we're looking at the costs here show you that most of the energy, the cost goes into the delivery, distribution, and storage of all of this hydrogen. So ours is extremely just minimal. I can't wait there. So the other part is that if you're going to use pipelines, you're going to be losing about 1.4% for every 150 kilometers of loss to energize the compressors and loss through the pipeline itself. So an on-demand, decentralized approach gets rid of all of these problems. And we can then look at an approach where you can do on-site production wherever you need to be. We change the game in terms of certain kinds of opportunities, which I'll get into in a second. So our catalysts can be reused. Some of the catalysts we've done are about 3 to 8 times we can reuse them. Then we can repurpose the catalysts for other applications, other nanomaterials. So we can amortize them. So the catalysts are very highly efficient and for energy conversion and utilization. And best of all, there are no greenhouse gas emissions. So our revenue streams. We're looking initially at remote sites, home reactors to power using gray water to power your home and feed in the
1 minute
gas
to go.
To essentially get you off the grid. Essentially, use instead of natural gas, use water to heat your home. Other applications that are being considered that we're in contact with a few companies is using on-site ammonia production for the agri-food sector. Lastly, we're in discussion with manufacturers to produce an onboard hydrogen system for hydrogen combustion engines, so to compete with electric vehicles. On the business development side, we've got 2 patents that are being prepared and more expected. We've got NDAs signed with several North American oil and gas companies. And there was ongoing discussions with green energy transition companies in Asia and Europe. Since we launched on Monday, we've got emails coming in from all over the world. One of the biggest ones is cement manufacturing. They want to use hydrogen to fire their kilns. The next stage of our development is to do multi-kilogram catalyst batches and to achieve a construction of a 5 to 10 kilowatt fuel cell system that we can use to demonstrate for in-home and remote uses. Lastly, we've also done a few other things in the labs where we've done proof of concept for methane pyrolysis at low temperatures, about a third the temperatures of traditional ways, and we can convert plastic back into hydrocarbons using the same similar catalyst family. Our initial raise is about $2 million, but after this week, I think we'll have to up it by a factor of 5. Thank you very much. So, any questions?
So we're going to have some for you.
Okay.
So I know we spoke a little bit, so I'm going to kind of repeat some of the questions.
Sure.
So can you talk about how long it would take you to create 1 kilogram of your catalyst, and then how much hydrogen would that produce?
Okay, so that little reactor that we're doing is doing 5 to 7 liters of hydrogen per hour with 1 gram. Okay, so you do the multiplication in your head. Okay. To produce that catalyst, we're at the stage now where we're producing hundreds of grams of catalyst in a batch. And that's just in a small little reactor. Our labs now have the capacity to do much, much more, 5 times that much. So we could do maybe almost 1 kilogram per batch. So, and that's just lab scale. If we moved into a full production facility, we could produce kilograms on a daily basis.
So the $2 million raise, largely what are those funds going towards right now?
So the $2 million is used for the scale-up of the manufacturing, as well as the building of the fuel cell chemical power units. So that would be like a dishwasher-sized system, which would be about 10 kilowatts. So that's all the engineering, that's all the architecture and the systems development, process control, et cetera.
Your product sounds almost too good to be true, which is what.
So did we think when we first saw it.
But this is what a lot of people will say. So I foresee that you're going to have a big communication problem. How might you start to tackle that and overcome some of the perceptions that might exist around your solution?
So I'm going to tell you a story. One of our company officers was in the UK. He's flying back to Edmonton. He's sitting on the plane. There's a guy with his iPhone. He's looking at it and saying, wow, that's a cool, really discovery coming out of the University of Alberta. And he looks at it and says, yeah, that's ours. This is going to go viral because people don't care how it's made. They just want to see the results and they want to use it. And that's what we're seeing with the input of emails that are coming into us right now. I've got people emailing, they want to invest already. They haven't even seen the videos. They haven't even seen it in person, and yet they'll invest because they're looking at the end product and they have a vision. So I don't think the communication is going to be too much of an issue because if you just go over there, you can see it running. You can see for yourself how simple and how easy it is. The technology is in the catalyst itself. That's the composition of matter that we're patenting that nobody will ever be able to copy.
And are you able to take this out of the university at this point, or do you still have to kind of work on that?
It's already in the process of being moved out. We've already got labs set up. We have the parent company, Applied Quantum Materials. We're a global leader in silicon nanomaterials. We ship all over the world. We have labs set up with the equipment that dark matter materials will be using to accelerate their growth. So we can eliminate a lot of the capital required to get the company started. So we've got separate labs set up already for them, as well as they can use and borrow our equipment as necessary to scale up and do the demonstration for people that want to take a look.
So at what point, if you scaled up, how much activator or how much product would you have to manufacture in order to be profitable in the next, let's say, 2 years?
So I would say once we've got to the hundreds of kilogram scales, we'd be profitable. because at that rate you're producing enough material on a constant basis. It really depends on the end user and their acceptance of the product. So from the interest that we've got already, the cement plant, well, that's going to take a ton of catalyst to run continually. So that one customer will pay for everything. So we're doing an NDA and a video conference call with them next week.
Thank you so much for your time.
You're welcome. Thank you, everyone.
And the demo is right over there with the University of Alberta signs, correct? Right over there.
Thank you, David. Moving on to our next presenter. Can you click it? That's okay. All right, moving on to our next presenter, we have Todd Luker, who is the co-founder of H2 Link. I will leave it with you.
Hello, everybody. Thank you for being here. I want to say a big thank you to Plug and Play for organizing such an amazing event. We really appreciate the opportunity. So, as most of you know, the hydrogen industry has been seeing some phenomenal growth, particularly in the areas of production and also in use by many different industries. But there's also some serious challenges in the supply chain and the transportation systems that link them together. So we need it to be reliable, safe, and economic in reaching any of the desired markets. Now, let's put that into perspective. In the last couple of years, we've all seen major disruptions in supply chains in our day-to-day lives, and we've experienced stress and all kinds of hassles related to those supply chain disruptions. In the hydrogen industry, the early adopters have expressed to us they're seeing some of those same frustrations as they're moving into hydrogen. They're seeing it on a much bigger scale, and they're seeing that it has some real significant impacts. One particular instance is we've been talking with a major fuel supplier in the trucking industry, and they have said to us, as they move into hydrogen, if they do not get their hydrogen supply chain figured out, they are looking at a 40% market disruption. So let me say that again. If they don't get their hydrogen supply chain right, they're looking at a 40% market loss. So in response to that, we're looking to help them, of course, by addressing several supply chain related problems. Number one, and that's always a big one, is the chicken and egg scenario. You need to have supply and demand along with the connected infrastructure to be able to reach your desired markets. Number two, hydrogen is tricky stuff to handle and to transport. So can you actually move it through the supply chain in an effective, reliable, cost-effective manner from supplier to that end customer? And number three, as markets change and adjust, can that supply chain actually be responsive and do what it needs to and respond to the market? So, as a manufactured product, that represents some significant challenges, actually, but we actually see it as representing some significant opportunities. So this is where our company comes in. H2 Link is a software platform. We serve as a hydrogen supply chain as a service. It provides a tool that identifies and compares all possible routes and options for the end-to-end supply chain. So whether that is trucks, pipelines, or rail, or shipping, or any combination, all potential suppliers come together. All potential suppliers, transporters, and customers come together and connect. We then transact them and pull them through a demand-pulled supply chain. Now, I want to be clear. We are much more than just a matchmaking marketplace. We actually identify all the paths and help them assess those paths from a financial perspective, from a technical perspective, from a sustainability and safety and risk. So we create value for all the participants in the supply chain. We help them create a stable supply chain that is economic, that is adaptable to market changes, sustainable, and cost-effective. So for our business model, our model is set up as a multi-sided marketplace where we bring significant value to all three sides of it, and we are able to generate recurring revenue through a subscription model that is tied to the volume of hydrogen that moves through our platform. Now, we believe at this stage that that revenue will come from the customer side of the model, but there is the potential that we can generate revenue from all three sides, potentially all at once, but all three are options. So, here we're, oh, sorry. So it's tied to the volume of all three market sizes. We are making significant progress and have been pushing forward with customer development. We have a prototype in place. We are working with a major fuel provider across North America. We're dealing with a city-owned utility and fleet, and we're also dealing with a hydrogen producer, an oil and gas producer that is now producing hydrogen. And we are ramping this up rapidly. So the market sizing, as a marketplace, we have the potential to cross many different market verticals, but we are focusing on a couple first movers. So one being the trucking fuel industry, two being forklifts in warehouses, and three being city-owned utilities and fleets. In this particular graphic, we are showing the trucking industry with its $60 billion of diesel moving to $30 billion of hydrogen by 2030. And we intend to be one of the tools that helps to make that happen. So, in order to make this happen, we have a strong founding team to tackle this challenge. My co-founder, Tricia Kennett, who's right over there, she's got 25 plus years of experience in engineering for pipelines and facilities. So engineering, inspection, regulatory, and assessment. And myself, I've got 20 plus years of experience in business development, strategy, software, innovation, all in the pipeline space, and have considerable hands-on experience in agriculture, transportation, and in oil and gas. So, as part of our ask, we are looking to add to our team. So we're looking to bring on a CTO as our next person on our team. Also, we want to connect with more early adopters in the trucking industry. We also want to connect with early adopter producers, transporters, and end users. And finally, we are looking to raise our seed round of $500,000 for product development and commercialization. We haven't officially launched our fundraising drive as of yet. We're about 2 months out, but we're looking to start making those connections and conversations now because we know it's a process. So, in conclusion, we are tackling a significant industry challenge. We are working with early adopters who are confirming that it is a significant industry challenge. We have a strong business model, and we're working on a big market problem. And we have the right team to execute on it. So we're happy to take any questions and connect with anybody who's an early adopter, an investor, or come talk to us.
Thank you so much for the presentation. So I just want to kind of also clarify. So this has been bootstrapped for the better part of your time. Now in the next 2 months, you're going to go after your first round of funding. My understanding, your product is kind of like a hydrogen marketplace almost, where you're trying to really connect all the different players together.
Yeah, because we see it as the marketplace as that it'll be continually changing and evolving as demand pulls, also as supply changes. So we would be a marketplace that connects all the pieces of the path from production to to the end customer, or vice versa. So we would allow them to transact, as we were saying, through that marketplace. And as it passes through possibly many different hands, whether that's a pipeline, a trucking company, the producers, the compression, the liquefaction, any of those stages, we would help move it through that and actually make it seamless, essentially.
Where did the idea of the business spawn from?
Yeah, so myself and my co-founder, we come from the pipeline world. So as we started to see some rumblings of hydrogen, we thought, well, this looks excellent, but you know, we've dealt with hydrogen in the pipeline space, especially with H2S. And so one of our concerns right away was like, okay, what does that look like for all the infrastructure that was going to get it there? So that led us to dig in, and we started really getting into the problem and seeing like, okay, this is more than just a materials problem. This is a whole supply chain problem. For it to be resilient and for companies to make, you know, multi-billion dollars of investments, they need to know that there's more than just like one source of hydrogen. They need to know that it's a resilient system that is going to adapt to the market needs.
When you talk about a hydrogen marketplace, one of the big contentious issues when it comes to hydrogen is it gray, is it blue, is it green? And this is important to a lot of end users. Does your marketplace note source of hydrogen and color and carbon intensity?
We know the source, and we've debated on this exact subject. Like, do we actually track the carbon? We think there's a lot of people who are doing that, and we think we're better to work with the people who are tracking the carbon. We would absolutely be able to know from that process, you know, where the carbon is, the fact that it's been accounted for. So it's not just a matter of, oh, it's been produced, forget about it. You obviously need to know the source. We have the ability to model that whole system from end to end, so we know what it starts as. Basically where everything went, like down to the substance level, whether that's gas composition, whether that's actual CO2. Yes, we have that ability.
So last question, how much do you make percentage-wise per transaction? Or what are you kind of targeting for that?
Yeah, we actually haven't calculated that percentage yet, or we haven't come up with that percentage yet, because right now we're still working with those early adopters, and so we're trying to work with them to see what's going to be feasible. Obviously, we need to make money, and we're not shy about that. So we're being very upfront that as we're working with these customers, we're trying to develop a business that's going to be massively profitable, and it's going to help them. So we're not being shy about saying like, hey, help us develop the business model.
Fantastic. Todd, thank you so much for your time.
Thank you, guys.
Thank you. All right, thank you, Todd, so much. Next up to this stage, I'd like to introduce Ambrish. He is the co-founder of Nanodes, so I will leave it with you.
Hello, everyone. Thank you for being here. I am Ambrish, and I'm a co-founder of Nanodes. And we at Nanodes make nanotech-enhanced catalysts and electrodes for alkaline water electrolyzers. So, as we all know, that use of hydrogen as a fuel is important to meet the net zero carbon emissions by 2050. And currently, there are three kinds of hydrogen available in the market: gray, blue, and green, with green being the most sustainable with zero emissions associated to it. And when it comes to green hydrogen, there are various ways to make green hydrogen through water electrolysis using alkaline water electrolyzer, AEM, PEM, and SOEC. But currently, the alkaline water electrolyzers dominate the market with over 60% of the market share, and they are forecasted to maintain the status quo in the near future. But they have their host of challenges which they need to address, which needs to be addressed for them to solve the rising demand of hydrogen production. So let's talk about some of the challenges and the targets of alkaline water electrolysis market. So currently, one of the bigger challenges is capex of the alkaline water electrolyzers. This is due to the fact that their current densities are not very high, so they need bigger surface areas for per unit hydrogen production, which drives the need for bigger modules, which drives the capex. And then there is the problem of OPEX, because they have poor electrical efficiency, because of which they need more electricity to produce per unit of hydrogen. That drives the cost of electricity. And then there's a problem of maintenance because of the catalyst degradation. So the catalyst used in the alkaline water electrolyzers these days is not suitable for high current densities. It degrades at high current densities. And then there is operating constraint. So the catalysts are also limited by the maximum temperature at which they can operate. Usually the chemical kinetics of a reaction increases with the temperature, but the alkaline water electrolyzers are limited with at that front because their catalysts are not stable at high temperature. So we have figured that all of these problems can be solved by developing novel catalysts and electrode which have better performance. So that's exactly what we have done. So in the past 3 years, we at Nanodes have worked and did our research and development to make nanotech enhanced catalysts which are completely metallic. And our catalysts provide host of improvement such as 3 to 5% hydrogen production, twice the operational life, 80% lower manufacturing time, and inherently sustainable manufacturing. So the way we manufacture our catalysts is very simple, very scalable, and uses no exotic chemicals in the processing, so which makes it inherently sustainable. Whereas it's very quick, which reduces the manufacturing time compared to the regular catalysts which are used in alkaline water electrolyzers. And since the nanostructures here are metallic in nature and they're a part of the substrate, they are grown on the electrode through in situ growth using proprietary patented technology, which enables it to have higher performance, like 3 to 5 times because it can sustain the high current density without degradation, and it can operate at higher temperatures, which gives all of the properties. Currently, we are at a TRL 4 stage, and we have a patent published for this technology. And we have demonstrated the use at lab scale, and we are looking to take it to now we feel that the technology is scalable and ready for the industrial application, so we are ready to scale it up. The scope for growth. So the global electrolyzer market is forecasted to grow at an unprecedented CAGR of 32.2%, which puts our total addressable market at $7.4 billion in 2022, with a total serviceable addressable market at $4.5 billion and serviceable obtainable market at $1.8 billion. So our business model is we want to get into the B2B market and make customized electrodes and catalysts for the electrolyzer OEMs like Toshiba, Siemens, Ballard, and Nell, etc. So we aim to leverage the OEM value chain to accelerate our market entry. Our team has a healthy mixture of research and development, engineering, and business development expertise. Our research endeavors are led by Professor Harpreet Singh Arora, who has over 15 years of experience in metallurgy and electrochemistry. He holds multiple international patents and has published in the top journals in the world. Arpit, who is our Chief Innovation Officer and Technology Expert, is a student at Dr. Arora's lab, and he also has a patent and has published in multiple journals. Whereas Siva and Rutvik bring the business development and engineering and quality lead expertise to the team. And I am the CTO, and I look after the technical operations of the company. So our ask is we are looking for strategic partners, we are looking for advisory board, and we are looking for pre-seed fundings to take our technology to the next level. Thank you.
Thank you so much for your presentation. Kind of what you were kind of hinting at the very end there, is this still within a university? And you're going to be kind of spinning it out, or is it already spun out and you're looking to take it further?
We are still in the university stage, and we are looking for strategic partners to, for product market fit, basically validation. So we have the results at the laboratory scale, and now we are looking for strategic partnerships with the industries to take it out to the industrial scale. Yeah.
So being at the university right now, that IP is it owned by you, or who?
It's owned by us. Okay. It's owned by us. It's not by the university. Yeah.
Okay, that actually changes things.
Okay.
So how much are you targeting for your I guess your first fundraising?
Yeah. So we have an estimate of about $200,000 that we will need to take it to for the manufacturing capabilities and manufacture our electrodes and catalysts. That's the initial ask that we are looking to raise.
So where's the initial manufacturing going on right now?
Right now, it's based in India. We aim to bring it to Canada. That's why it's such a high ask, because our technique is not very demanding. It's cheap to make. But in Canada, taking into account the cost of manufacturing, that's why we need that kind of money to raise, to bring our manufacturing to Canada.
200,000 is not a whole lot. Just bluntly, in startup fundraising terms. It's usually like a minimum million. So ask for more.
Okay, sure.
You had a piece on the slide that said no exotic
Chemicals.
chemicals. Explain what you mean by that.
Sure. So our manufacturing of the catalyst and electrodes, we use a thermomechanical process. We don't use any chemicals for making those catalysts. We do not use any kind of hydrothermal or solvothermal technique to make these catalysts. It's a completely thermomechanical process, our proprietary technique that we developed and patented. Yeah.
Now, one of your asks, I believe, said pilot partners as well.
Yeah.
Who would be an ideal pilot partner right now?
Someone like Cummins or Nell, who work in alkaline water electrolyzers, and if we can make catalysts for them, which they can put in their device and validate.
Is the company currently incorporated in Canada? Or
Yes, it's incorporated in Canada. Yeah.
Thank you so much for your
Thank
time.
you.
Another round of applause, please.
All right, thank you to all of our wonderful founders and technical experts at these really fascinating companies that are located all around the world. So thank you to Edmonton Global and to Plug and Play for putting this together. We are gonna collaborate for the next, or collaborate, yeah. We're gonna take the next 10 minutes and we're gonna pick a winner. The winner is gonna get a spot in our Plug and Play Alberta program, as well as a place to pitch on our global stage at our Plug and Play Summit in June.
All right, good afternoon, everyone. So I first want to thank all the startups again for pitching. I know this is really difficult. So let's give another round of applause for them. So before we kind of wrap today's session, I wanted to again say thank you so much for everyone for joining us. And can we get kind of an impromptu drum roll, I guess, on the thighs? So after a lot of really good kind of debate with my other judge and I, it was a really close call, but we are going to go with Golu H2O for kind of the invite for the expo. But again, let's give another round of applause for all the startups.
Again, thank you to all of our participants throughout the full 2 days of our innovation stage. Thank you to Edmonton Global for collaborating with us on this pitch competition. You guys were vital to the application portal and everything in between, so thank you very much.